The next speaker is Franck from USA, citizen science astronomy with Unistellar Network, please. Franck, unmute, please.
Hi, sorry. How are you? Good morning, good afternoon, good evening as well for the one in the US. Thank you very much for inviting me to give a talk at this very interesting conference. We have great talks this morning and this afternoon, very inspirational. Unfortunately, I didn't have time to include some of the ideas in my talk, but I'm telling you that I learned a lot and I'm going to change significantly some part of my presentation to include some of your ideas. So it was great. So I'm going to talk about Unistellar. Unistellar is a private company with a headquarters in Marseille in France and offices in San Francisco. The company has designed the first smart robotic compact telescope, a telescope for everybody, a telescope that will allow to democratize astronomy. On the top of building a telescope, we are now users and we are generating sky data. And this could be used for citizen astronomy, citizen science. So some of you may know us because in 2017, we did one Kickstarter where we pre-sold 2,500 units. And now we are in the process of delivering those units to our backers around the world. This is a picture that we take recently of the company that grew significantly over the past 2 years. And we have an office in San Francisco in partnership with the SETI Institute. And this is some of my collaborators who has been working on the citizen science with the eVscope. So I'm gonna essentially present their work since I'm the lead of the scientific group of the SETI Institute for Unistellar. So the eVscope is a telescope. It's a telescope which is equipped with electronics. It's a telescope which is a consumer product that you can buy in various places. We have now distributor in the US and in Europe. It's equipped with what we call an enhanced vision, which is an algorithm that stacks images over time, allowing you to see like if you had a 1 meter class telescope in your garden. It's a portable telescope. You can carry it in a backpack. I have one here behind me, so you can see the size, scale to me. And it has a design which is appealing and interesting. We'll see that later. It's also an education device. You don't need to know anything about astronomy. Thanks to the eVscope, you will basically learn. So first you set up the telescope. The app will give you some suggestion of objects you can observe. The telescope will align itself, and then you will be able to observe in your garden in less than 5 minutes. And it's connected, meaning that we use an app to communicate with it. So this app can also communicate with other users. So this eVscope, as an eVscope user, you receive notification and you can participate to observation campaigns. And is also useful for science because of its sensitivity. We can reach magnitude 16 in cities, 18 in the countryside. Its accuracy, you can do photometry as well. And also because of the campaign modes that we are developing around the telescope. So this is a bit of detail about the hardware, but basically what you need to know is that the light, it's a Newton telescope. So there is a primary mirror, which is 4.5 inches, 11.2 centimeters. At the primary, we put a sensor, which is basically a CMOS detector. They have a computer here which analyzes in real time the image, do some correction of the image, removing the effect of the light pollution, for instance. And then we have a live projection device here, which is basically an electronic eyepiece. So you see the image getting better as the telescope is collecting more and more photons. So we have on board the telescope, we have a very complex software that we have developed ourselves. One of the key here is the autonomous field detection, which is basically a plate scaling, but very fast. So that you set up the telescope, you press align, and the telescope finds where it's located thanks to the app, the time as well, thanks to the app, and it aligns itself. Then in the database, we had objects of interest. So of course, we have all the Messier objects, a large number of NGC targets. We are putting more and more objects as the software is evolve and change. We have now also 4,000 asteroids. So this is the picture we show when we were doing our Kickstarter. That's what we have, the classical telescope on the left, and that's what you can see with our eVscope after a few seconds. Those are observations taken from San Francisco and from Marseille of M51 and M27. And as I say, this telescope does work in cities, and that's the key here. We really want everybody, even people living in city, to be able to enjoy the dark sky. Of course, if you live in the countryside, the image quality is better. You can even see fainter objects. So we have delivered the first telescope. We have delivered more than 1,000 units now. So we are getting pictures taken by people around the world. This is from the Orion Nebula from Alain Vézina. This is Uranus, and you can see Oberon and Titania, the moon from France. Those are a picture taken from one of our citizen astronomers in Réunion Island, the Trifid Nebula and the Lagoon Nebula with our eVscope. And this is the galaxy M101, and on the right you can see the comet TOIs. So this is kind of a combination of multiple observations taken by an observer while the comet was getting closer to us. So we can do interesting things as well, like we can create a super telescope. So in this case, what we do, we send notification to our users, telling them to observe a target at the same time. In the case, we did this for the Comet Atlas. So that's an observation of the Comet Atlas from my garden, San Francisco, here. And 40 citizen astronomers in Europe observe at the same time the comet on April 11 and 20 on April 14. So these are the result of the combination of all the observations taken by this citizen astronomer. So we increase the signal to noise, of course, because we combine observation. And here we reach magnitude 18 without any problem on these observations. People do some great stuff with this eVscope. There is a challenge now to observe the faintest and the most distant objects. So Frederick Davis, one of our backers, has been observing a quasar, which is 12.3 billion light years away from us. And this is taken, you can see it here, with the eVscope from a garden in Arizona, in a suburb. So that's what the apps look like. So you can get, this is what you get on the app. You can control the telescope with the app. You control the telescope with the app, but you can also share. Multiple people can be connected on the telescope at the same time. So see what the telescope is doing. There is an operator and viewers. You can select the target. There's a list of targets recommended by us, but then you can explore more and more targets. You can also point at different positions if you know the radix of an object. This is the science mode. I'm going to go through that later. This is the image gallery. You can save your images. And this is some information, technical information. The app is currently available in English, French, German, and Japanese. So it's a great telescope for enjoying the dark sky, for learning about the dark sky, observing galaxies, nebulae, and so on. But it's also a telescope for science. And that's one of the reasons we partner with the SETI Institute. Someone mentioned astronomy has always been a science which has a contribution of a lot of non-professional astronomers that we used to call amateur astronomers, and I will call citizen astronomers. And these amateur astronomers have been using the telescope in the garden to observe and discover a lot of interesting targets. Some are, for instance, the most recent one, the interloper comet Borisov was discovered by an amateur astronomer. So we partner with the SETI Institute to basically do the same for our entire network. So the idea here is that SETI will curate requests for observation coming from professional astronomers. we will send notification to users around the world. They will take the data, send us the data, and we will send them a report, an image, an animation showing the result of their observations. So we identify four science cases for which we could use our eVscope. And I'm not gonna talk of all of them because I don't have time, but I'm gonna mention the planetary defense, the study of asteroid by occultation, and the study of exoplanet by transit. So we have been using already the eVscope for observation of asteroids. So this is what you see when you observe an asteroid from San Francisco, for instance. That's Florence, 1999 KW4, which is an NEA, and Eros, which is the largest NEA. So what you see in this case, because you integrate a large amount of time and the NEA move with respect to the dark sky, to the stars, you see basically a line, okay? But the images are saved individually. So you can also analyze each image one per one. So this is interesting because we are proposing to expand basically the number of stations around the world that will be able to capture quickly an image of an asteroid which is flybying Earth. Most of the time we detect those a few days before the closest approach. So having those small telescopes distributed around the world will allow to basically fill up the gap that you can see in the world here, especially in Africa, in Asia. So this is one of the interesting part of this telescope, is that people can purchase it, or school can have it, and can be anywhere in the world. So we've been working, I'm not going to go through that in details, but with professional agency to create an alert system. So now if an NEA is observable with our eVscope, so it has a magnitude of less than 16, we receive an alert. So in the future, we'll be able to send this alert to our entire network. So if you're observing in your garden this tonight and there is an NEA flying by Earth, you get a notification on your phone saying, hey, there is a new asteroid that we would like to get additional information. Do you want to observe it? You say yes, the telescope will slew to the right position, search for it, take data, and send the data to us. We process the observation and send it to the MPC. In fact, we are already doing this in our way. So this is, for instance, an observation in 1998 OR2 from San Francisco. And this is a lightcurve of an asteroid, a main-belt asteroid that we collected with our eVscope. So we are now capable of doing astrometry and photometry with using this small telescope up to magnitude 16. We're doing also occultation. So in this case, what happens is that you don't see the asteroid, but you see the disappearance of a star because the asteroid is crossing the path of light of the star. So you have a shadow on Earth, a tiny band, a few tenths of kilometers generally. So if you're located at the right place at the right time and you're observing the stars at the right time, you will see basically the star disappearing. If you have multiple observations across the band of centrality, you will be able to get the shape, the size of the asteroid. And if the asteroid, like Pluto in the case we have here, has an atmosphere, you will also see the atmosphere, detect the atmosphere. So that's what we did here, for instance. That was in August 2018, the 15th of August 2018. We observed an occultation by a star magnitude 13 by Pluto. And what you can see here is the presence of the atmosphere of Pluto. So those are kind of observations are done in group generally. You go, you drive, and you dispatch people around, and they observe it. But since we will have a lot of telescope, we are not able to even send alert to people from their house to tell them when there is an occultation that will be visible in their house. So we have done that. It's not science fiction, it's real now. And in fact, we had the first observation here of an occultation by Moran, a citizen astronomer in Brittany. He got a notification from us, and he observed the disappearance of an asteroid, which is called 2000 UD52, small size asteroid, 7 kilometers. And this is the observation he collected. You can see the star disappearing for around 0.3 seconds. Is my time? No. So
Yes,
this,
5 minutes.
okay. We have done as well, we help NASA. We went to Oman to observe the occultation of a Trojan asteroid. You will see the star here disappearing. It will disappear for typically 5 seconds. And that's the occultation you have here. So this is very interesting because this asteroid is is a target of the Lucy mission. So here we're working with a space agency, NASA, to provide scientific data that will be useful for them because they don't know the size of the asteroid, they didn't know really the position of the asteroid. With this, we nailed down the position accurately. And we are participating now to campaign of observation, targeting specifically all those 6 Trojan asteroids that will be visited by the Lucy mission. And then we also do transiting exoplanets. So it's a small telescope, but with the quality of the optics we have, we can detect transit with a depth of around 1%. So it means that we can detect Jupiter-sized exoplanets orbiting around G-type stars. So we did the first test in 2017, that was HD 209-458b. And now we send alerts regularly to our users, our backers, our citizen astronomers, to tell them when there is a transiting exoplanet that will be visible from the location. So we got recently, in April 20, the first observation of a transiting exoplanet by Julien, that you see here, and a backer of our Kickstarter campaign, who observe the transit of this Jupiter-sized exoplanet. So the goal here is to observe them, okay, and to also quantify, refine the orbits, and be able to see the surrounding of the planet. So I'm not going to go through that because I don't have much time, but we are now helping TESS with this project. We will be able to observe 200 exoplanets detected by TESS to confirm their existence and to also refine the orbit of those exoplanets using this small network, this large network of small telescopes. So where are we now? Where we are, that's what we promised to our backers in our Kickstarter campaign, that we'll be able to send notification and etc. That's what I described. We are not there yet. We are learning how to do this, how to process the data and so on. But we have already implemented some pilot programs for occultation, for exoplanets, for planetary defense. And we're going to continue this with comets and soon transiting exoplanets. This we allow our backers to get notification on their phone, participate to campaign, process the data themselves, learn how to do it, interact with each other as well. And that's very key for us. We want the citizen astronomers to take ownership of the scientific discovery they do and to learn how to do the analysis themselves if they want to. So I finish by saying we have demonstrated in 2020 that we can do interesting science with this eVscope network. We think we have succeeded in bringing with this telescope the joy and the excitement of discovery in astronomy, and this will go to houses, but also to what we hope in classroom. More and more teachers have been contacting us to purchase a telescope, to learn how to use it, and etc. We're open to collaboration with cities, with space agencies around the world, also informal education center. We're starting a project with JSOU, ASP, and the American Modeling Teacher Association to basically bring the eVscope in school and give the opportunity to the students to learn astronomy by using the telescope, by processing the data. And I will hand here, we can read the rest of the slide. Thank you very much.
Thank you, Franck. There is one short question from India. What will be the cost to buy this from India?
So right now we're selling the telescope for 3,000 euros or $3,000. If you are in India, we don't have yet distribution in India, but we will in the future. So if the person is interested, can contact me, and my email address is here. By the way, my email address is wrong. I don't know. I put my wrong email address. Let me just change this. It's not. Very weird. Anyway, yeah.
Okay.
Excuse me, Hitoshi, I have a short question. Do you,
yes.
Nice presentation, Frank. Do you have also a program where, for instance, a Ministry of Education could develop not only the purchase of a telescope, but also education program that go with it? So how can teacher develop educational content making use of the eVscope?
So we have been approached by universities for this. In France, we've been approached by 2 engineering schools who want to basically develop the curriculum around this, the eVscope. So yes, we are interested in, as I say, we are a small company, we can do everything. And I know people do better, do stuff better than us, especially in education. So that's one of the reasons we are partnering with GHOU and so on. So if you think about an education center in Europe that would be interested, let us know. We are open to collaboration.
And ESA Education Office also, certainly.
Exactly.
Thank you.
Yes, thank you. Another question. What are your hopes for Unistellar in the next 5 and 10 years?
In the next 5 and 10 years, wow. The goal is to create a network of citizen astronomers. The goal is to really be able to create a community, okay? And this community will basically use the eVscope and develop by themselves new project. That's our goal. We don't want to do everything. We are providing the infrastructure, basically. It's like when personal computer came. We give people personal computers, and some people are starting making games, some people are starting making graphic design stuff, etc. We want the same to happen with the eVscope. In 5 years, 10 years, we hope to have, I will not say 1 million telescopes on the planet, but a large number of telescopes. I will say 100,000. But what's very important for us is not only to have those telescopes in the hand of people, we want the people to use them. So that's the reason we have done this object. It's not only because one of the problems we have in astronomy is that people buy telescopes, they learn how to use it, and the person who is an expert disappear because goes somewhere else, and then the telescope end up being in the basement of a university where nobody knows how to use it. So these telescopes will not be that. We want this telescope to be used intensively by people, and the software will change. There will be improvements, and of course, we probably will have new models coming out later on. So maybe lower cost, maybe bigger size. We have different vision at the moment, but it's not yet clear what we're gonna do. But we will diversify as well in terms of the telescope.
Thank you very much. It is very excellent idea to not only buy the telescope, but also promote the usage and the student science. Okay, any other question? If not, we will have 5 minutes break to the next speaker. Thank you, Frank.
Thank you very much.